Hello learners, we are going to start with the topic permutation and combination. It deals with selection and arrangement of things. It starts with introduction to factorial and fundamental principle of counting. Further, it includes the concept of permutation, its notation and formulas. For better understanding of the topic, permutations are applied to solve real-life situations. Further, it also covers the concept of circular permutation. What is the need of permutation and combination? In our daily life, we come across situations when we have to select some things, and we can select them in many ways. In every situation, it is not possible to write all possible ways to select the particular item, and it is known as combination. If the order of selection also matters when we arrange things, that is called permutation. To do this topic, one must know about factorial. In this video, we will have an introduction of factorial and fundamental principle of counting. Factorial is a very simple and interesting term in mathematics. Factorial of n means the product of first n positive integers. It is denoted in two ways as shown in the slide. Let us take some examples. 5 factorial is equal to 5 into 4 into 3 into 2 into 1, which is equal to 120. 7 factorial is equal to 7 into 6 into 5 into 4 into 3 into 2 into 1. It can also be written as 7 into 6 into 5 factorial. Substituting the value of 5 factorial, we get 42 into 120, which is equal to 5040. So, n factorial is equal to n into n minus 1 into n minus 2 into n minus 3, so on up to 3 into 2 into 1. Factorial of n minus 1 is equal to n minus 1 into n minus 2 into n minus 3, so on up to 3 into 2 into 1. Hence, n factorial is equal to n into factorial of n minus 1. Here are some key points to remember. Factorial of 0 is equal to 1. Factorial of 1 is equal to 1. Factorial of fraction and negative integers is not defined. Let us prove factorial of 0 is 1 since n factorial is equal to n into factorial of n minus 1. Put n is equal to 1. We get 1 factorial is equal to 1 into factorial of 1 minus 1. 1 is equal to 1 into 0 factorial, which gives factorial of 0 is equal to 1. Now, let's solve some more questions on factorials. Calculate factorial of 6 by factorial of 4. Now, 6 factorial by 4 factorial is equal to 6 into 5 into 4 factorial by 4 factorial. Cancelling factorials of 4, we get 30. Let's solve one more question. Is 2 factorial plus 5 factorial equals to 7 factorial? Here, 2 factorial is equal to 2 into 1, which is equal to 2. 5 factorial is equal to 5 into 4 into 3 into 2 into 1, which is equal to 120. 7 factorial is equal to 7 into 6 into 5 into 4 into 3 into 2 into 1, which gives us 5040. So, by substituting the values, 2 factorial plus 5 factorial is equal to 120 plus 2 is equal to 122, which is not equal to 7 factorial, that is 5040. Let's solve another example. If 1 by 6 factorial plus 1 by 7 factorial is equal to n by 8 factorial, find n. Here 1 by 6 factorial plus 1 by 7 into 6 factorial is equal to n by 8 into 7 into 6 factorial. Taking 1 by 6 factorial common and cancelling from both sides, we get 1 plus 1 by 7 is equal to n by 56, or 8 by 7 is equal to n by 56. By cross multiplication, n is equal to 56 into 8 by 7, which is equal to 64, which is the required answer. Let's solve one more example. If factorial of x plus 1 is equal to 60 times factorial of x minus 1, find x. Here we are given factorial of x plus 1 is equal to 60 times factorial of x minus 1, or x plus 1 into x into factorial of x minus 1 is equal to 60 into factorial of x minus 1. Cancelling factorial of x minus 1 from both sides, we get x square plus x is equal to 60. That is, x square plus x minus 60 is equal to 0. By using discriminant formula, we get x is equal to minus 1 plus minus square root of 241 by 2. These values of x are not possible as x cannot be in fraction. From here, we can conclude that no value will satisfy the given equation. So, it was all about factorials. Now we will discuss fundamental principle of counting. Let us suppose that we have to perform n operations. We have n1 ways to perform first operation, n2 ways to perform second one, and nn ways to operate nth operation. So, total number of ways is equal to n1 into n2 into n3 up to nn. Look at the example. In how many ways 4 people can be seated in a row containing 6 seats? Let's find total number of possible ways. First person has 6 choices. Second person has 5 choices. Third person has 4 choices. Similarly, fourth person has 3 choices. So, total number of possible ways are 6 into 5 into 4 into 3, which is equal to 360. So, 4 people can be seated in a row containing 6 seats in 360 ways. Our next question is, how many 6-letter words can be formed out of the letter of the word friend if repetition is not allowed? As total number of letters in friend is 6 and repetition is not allowed, so number of choices will reduce by 1 in each step. Thus, total number of possible ways is equal to 6 into 5 into 4 into 3 into 2 into 1, which gives us 720. Let's take one more example. How many 3-letter codes can be formed using the first letters of English alphabet if repetition is allowed and repetition is not allowed? In solution, let's find first total number of possible ways if repetition is allowed. Total number of possible ways is 5 into 5 into 5, which is equal to 125. As every letter has equal choices of 5 alphabets. Next, to find if repetition is not allowed. In this case, choices for every next letter will reduce. So, total number of possible ways is 5 into 4 into 3, which gives us 60. Thank you.